In this lesson, we'll be solving rational equations. If you recall, a rational equation is just a fractional equation. Keyword there is ratio. I want you to pause the video so that you may write these steps on your paper. You're going to need these notes to answer some questions later in the video. The first step says check for extraneous solutions. Extraneous values of x. I'm going to explain what that is on the next slide. The second step says get a common denominator, just like we did when we were adding and subtracting fractions. Third step says cancel out the denominators, and I'll explain why you can do that in a minute. Fourth step says solve the resulting equation, which will be your numerators and all appropriate signs, including the equal sign. You want to get your x's on the same side of the equation, that is if you have more than one x, and you'll combine your like terms if you have any, on independent sides of the equation. Then you'll solve for x. You'll get x by itself by PEMDAS backwards. So pause that video so you can write those steps. Now sometimes with fractional equations, you can actually work it out perfectly fine, make no mistakes, get an answer, but that answer be wrong. And it's because of the big rule that you can't have a zero in the bottom of a fraction. You can't divide by zero. These are called extraneous solutions, or also excluded values. When we do graphing next week, you'll relate these to the asymptotes. So looking at the first, here's the first problem. We're not going to solve it yet, we're just going to talk about what the extraneous solutions are. And looking at it, anything that would make the denominator equal 0. Because the denominator of a fraction cannot be 0. Not equal to 0. So here's a denominator. What value of n could you add 8 to and get 0? What plus 8 is 0? Negative 8 plus 8 is 0. So you would say that n cannot equal negative 8. That means if you work this whole problem out, do nothing wrong, and you get negative 8 as an answer, you would have to say there's no solution, because negative 8 doesn't work. Looking at the other denominator, what number plus 1 equals 0? Negative 1 plus 1 equals 0. So negative 1 is another excluded value for this one. N cannot equal negative 1. Okay, second problem. Here's the denominator. And notice we didn't even look at the numerator up there, because you can't have 0 on top of a fraction. It's just the bottom. What number minus 8 is 0? 8 minus 8 is 0. So in this one would say n cannot equal positive 8. Here's your other denominator, and it's the same thing, so it's going to have the same answer. And finally, down at the bottom, here's the denominator. What makes that denominator 0? If x is what number? Well, if x is 0, so x cannot be 0, because you can't have 0 in the bottom of that fraction. Here's another denominator. 5 times something equals 0. 5 times what would be 0? 5 times 0 would be 0. Well, we've already stated that there. X cannot be 0. Okay, now we're going to put all these steps into action. We're actually going to solve this equation. So you will want to write this example. So you'll have an example to look at when you're asked to do a question similar to it. Okay, step 1. What are the excluded values? Just make a note. Also called extraneous solutions. check those denominators and say 5 times what equals 0? 5 times 0 equals 0. So x cannot equal 0. Let's check that second denominator. 2 times something equals 0. 2 times what equals 0? 2 times 0 equals 0. We've already stated that, so we don't have to say it again. And there is no denominator here, so we're good there. Okay, so if we're thinking about going through the steps, that's our first step. Second step, we have to get a common denominator. Okay, even the whole number has to have a denominator. So right now, the 1 is over 1. We got to look at our denominators, and we got to make them all the same thing. What do we need? Well, let's just think about this one. What's this one have that this one don't? A 2. So I know right off the bat I'm going to be multiplying this one by 2. And whatever I do to the bottom of this fraction, I have to do to the top of that fraction. Moving on to the next fraction. Now I've got to make this one look like this one now. This is really 10x. What does this one need to be multiplied by? 5. So whatever I do on bottom, let's do the same thing to the top. Moving on to the end. What do we need to multiply 1 by so it'll be the same as both of these? Well, this is really 2 times 5 is 10, so that's 10x. 5 times 2 is 10, so that's also 10x. This needs to be 10x, so I need to multiply it by 10x. Whatever I multiply the bottom, must do the same to the top. Now you have to keep these problems neat and organized because they can get very hairy sometimes. Too much stuff in it. You'll lose something. So when you write the original problem, make sure you leave room to write in, unless you want to write it twice. Leave yourself room to write in these things that you have to multiply by to get the common denominator. Okay, so let's see what our new equation is. We will have 2 times 3 is 6. 2 times 5 is 10x, so we'll have 6 over 10x. Then we got 5 times 7 is 35, and that's also 10x. And make sure you bring down these important symbols like the plus sign and the equal sign. Those are very important. And then finally I have 1 times 10 is 10x. 10x over 10x. All right, looking back at my steps. After I have a common denominator, I can cancel out those denominators. And the reason being is that it's the property of equality. If you have these parts of the equation all equal, then that means their tops must be equal. So at this point, I can now get rid of these. Now, as long as I do the same thing on both sides of the equation, both sides of that equal sign, and that's legal. Let's write down what is left. We have 6 plus 35 equals 10x. Forgot to write what I did. Cancel denominators. Okay, step 4 says if you have x's on both sides of the equation, you need to get those on the same side. Well, I'm looking and I really only have one x. So I don't really have anything to do on step 4. We'll skip that step. And straight to step 5. Well, step 4 did say combine like terms. I guess I should have done that. Like terms. Because I can combine these two with 6 plus 35. 41. And then step 5 says do PEMDAS backwards. Solving for x means getting x by itself. Well, there's really only one thing with x, and it's the 10. If 10 is multiplied by x, the opposite of multiplying is dividing. So then we would divide both sides by 10. 10 divided by 10 is 1, and 1x is just x. And the same thing on this side. And you can divide that and make it a decimal for 0.1, but fractions, we leave answers as fractions in algebra quite frequently, so we'll just leave it like that. And then take one last look and make sure that your answer didn't turn out to be the same as your excluded value, and ours didn't. So we're good to go. That is the answer. Okay, don't sweat this one. Looks like it's very complicated, but it really isn't. Let's take it step by step. All right, do we have any excluded values in this one? So let's look at that denominator. Something squared times 4. Well, there's 4 times what number is 0? 4 times 0 is 0. So again, we got another excluded value of 0. B cannot be 0. And same principle here, 2 times 0 squared, 2 times 0 is 0. Same thing there. Okay, next step is to get that common denominator. So let's look at the smaller denominator. Is there anything I can multiply that by and make it the same as the bigger denominator? I can multiply this one by 2. And whatever I multiply the bottom by, got to multiply the same thing to the top, right? And how about this one on the end? Do I need to multiply anything on this one to make it like that one and that one? Another 2. So same, whatever I multiply the bottom, I got to multiply the top. Does that look right? So if I'm multiplying 2 to the top of this fraction, and it has more than just one term in it, is it okay just to multiply the 2 by the first term in that fraction? Absolutely not. We've got to distribute the 2, multiply 2 by both terms. So let's remember to do that. So now our equation looks like this. We left the first fraction the same. Second one is 6 over 4b squared. Be careful, b's and 6's can look a lot alike. If you want to change them to x's, that's perfectly fine. Probably a good idea. And then when we distribute here, 2b plus what? 2 times 4. 2b plus 8. And that will be 4b squared. Moving on to step 3. Now that we have the common denominator, we can do what with that common denominator? Well, if all the denominators are the same, then that means the numerators must be the same as well. If these equal this, then these are also equal. So we can cancel those out. And let's write down the resulting equation, not forgetting the plus and the equals. Those are very important. So we have b plus 6 plus another 6 equals 2b plus 8. All right, do we have any like terms that we could clean this up a little bit? These 6's we could add together. So it would be b plus 12. And in our steps it said if we have b's on opposite sides of the equal sign, Well, we can't just add them together like that if they're on the same side of the equal sign. So we've got to subtract one of them. And I think it would be easier to subtract the smallest one. Remember, that's 1b that we're subtracting. So 2b take away 1b would just be 1b. And finally, we're going to get b by itself. We're going to solve for b. And what is with b? The 8. What's the opposite of adding 8? Subtracting 8. And we're almost done. 12 minus 8 is 4. One last check. Let's just make sure that our answer is not the excluded value, and it's not. So we're done. 4 is the answer. Okay, last example. And let's take a look at this one. If I were going to do excluded values, or the denominator cannot equal 0. I don't mean just x. X cannot equal 0 every time. That's not what I'm saying. I'm saying this whole thing cannot result in 0. So what number plus 2 would equal 0? Negative 2. So let's just make a note up here in the cloud. X cannot equal negative 2. I'll make that in the cloud. Those are excluded values. Let's go to the next denominator. What number minus 2 would equal 0? 2 minus 2 would equal 0. So x cannot be positive 2. And then this denominator, what's another way of writing x squared minus 4? Doesn't it factor? How does it factor? It's the same as one of those difference of squares. Remember what multiplies to be negative 4? 2 and negative 2. And then how do you break x squared up? X and x, so it would be x plus 2, x minus 2. Okay, so let's look at that excluded value now. Now, what number plus 2 would be 0? Negative 2 plus 2. We already have that one. And what number minus 2 would be 0? 2 minus 2. We already have that one too, so we don't need to write any more excluded values. Now let's go to step 2, which is getting the common denominator. Let's look at the smaller denominators. This one, for instance. Compare it to the bigger denominator. What does this one need to be like that one? This one needs to be multiplied by x minus 2. And whatever you do on bottom, you must do the same to the top. That 4 will have to be distributed, but not this minute. We'll come back to that in a minute. Okay, next denominator. What does this denominator need to be like this bigger denominator? It already has the x minus 2. It just needs the x plus 2. So let's multiply that one by x plus 2. See if I can squeeze it in here. That's kind of messy, but oh well. And then this one already has x plus 2, x minus 2. So this one has x plus 2, x minus 2. This one has x plus 2, x minus 2. And so does this one. We can even step it up a notch if you want to. We can. They're all the denominators are the same. We'll go to step 3. If they're all the same, we can now cancel them all out. So now what's left are our numerators. Let's see if we can clean this up a bit. And don't forget this nice plus sign and this nice equal sign when you're cleaning it up. Okay, if we distribute the 4, 4x minus what? 8. So 4x minus 8. Let's bring this plus sign down. Same thing here. We're going to distribute 5 to both of those. 5x plus 5 times 2 is 10. And let's look at this equal sign. Let's not forget it. And this didn't need to be multiplied by anything because it already had the x plus 2x minus 2 denominator. So we'll just bring down a 29. Okay, next step. Let's see if we can clean this up any. Do we have any like terms we can combine? I think we do. Here's our equal sign. And all this stuff on the left side can be combined together. Now, you don't want to do minus 4x minus 4x. That would mean you're minusing 4x twice to the same side of the equal sign. If you're going to minus 4x over here, then it would be over here that you would minus 4x from. There's nothing over there to minus it from. So these are on the same side. We're just going to put them together. So we got a 4x and a plus 5x combines together to make what? 9x. And then we got this minus 8 and this positive 10. Again, they're on the same side of that equal sign. So we can combine those together. Negative 8 plus 10 makes a positive 2. Bringing down the rest of the equation. Now here's where we do the PEMDAS backwards. PEMDAS stands for parentheses, exponents, multiply, divide, add, and subtract. So if we're going backwards, start at the end. What's at the end? The adding and subtracting at the end. So we're going to do the add and subtracting first. So if we're getting x by itself, let's look and see. There's two numbers with x, meaning they're on the same side of the equal sign with x. And we're going to do the adding and subtracting first. So we're going to do opposite of adding 2 is subtract 2. And same thing on the other side of the equal sign. Some people like to draw a line when we're doing this. That's fine. 2 minus 2 is 0. So we got 9x equals 27. And then PEMDAS backwards, we did the adding and subtracting. Then we got to do the multiplying and dividing. So this is 9 times x. If we're going backwards, we're also going to do the opposite. The opposite of multiplying is divide. And the reason you do that is because 9 goes into 9 one time, and 1 times x is x. And then reduce the other side. 9 goes into 27 3 times. Make one quick check to make sure the answer is not one of the excluded values, and this one's not. So that is it. That's our final answer.